Hello! Welcome to another mother flipping stream. How about that? How about that? So yeah, today is Friday, and that means today, according to the schedule, we are doing random one of stream. That's what we're doing. And the topic of today's stream is Turing machine and programming in Turing machine, or programming Turing machine, whatever that's supposed to fucking mean. But my idea is I want to write a Turing machine interpreter as the first stage of today's stream, and then programming it. Just write some basic programs, right? Maybe something that sums up two numbers, maybe more arithmetic operations. Just experiment with that. So yeah, I decided to go with a pretty lightweight topic, so nothing complicated, just implement a Turing machine and programming it. So yeah, as you know, as people say, if it's Turing complete, I can program in it. All right, so let's turn off the music and get started. I wish I could actually stop this music. It doesn't stop because this web application over time leaks some memory and becomes slower and slower. I didn't know how, but because JavaScript is a garbage collected language, still over time this application becomes sluggish and slower. So it's kind of weird, I gotta say. It's kind of weird, but it is what it is. So let me bring, this is not what I wanted to bring. I wanted to bring something else. I wanted to bring the CHUD. There we go. So we have a CHUD, and let me close all of that garbage here. So, how everyone is doing? Hello, Iguduk. Hello, Shiggy Man, Lars, Iguduk, Hotzenplots, Prohimer, Shiggy Man, Scarface, Kill, Blast, Zero, Pond, Nipsey, Mr. Botka. Hello. I hope I didn't miss anyone. Hello. All right, I'm really glad to see you all today. We're gonna just start with implementing the Turing machine interpreter. We're gonna use D, because why not? So yeah, does anybody know what is a Turing machine at all? Maybe I just forgot to ask because I sort of assumed that everybody here actually knows what a Turing machine, but maybe that's a wrong assumption. Maybe a lot of people don't know here what is a Turing machine. So, you know, in a modern software development world, it's kind of dangerous to make these kind of assumptions. So who doesn't know what is a Turing machine? Okay, so Turing machine is a machine with an infinite tape, and a head that can read and write to the cells of that tape, right? So, and it has a state table that encodes the program for that head. So that table consists of several things. First of all, it consists of state, right? And head can be in a particular state. Then the read symbol on the in the current cell. Then write symbol, the direction where to make a step, and I guess that's it. So essentially, what head does on each iteration of execution of Turing machine. It looks at its own state, then it looks at the current symbol in a cell, right? And according to the state table, it rewrites the symbol accordingly, and then moves left or right, and then also switches the state. Like another column of that table is switching the state. So this is probably a very horrible explanation because I do not even have any visual representation of that table, so I'm just waving my hands in the air, and it doesn't fucking mean anything. But that's what it is. It's just a tape, head in a particular state, and a table with a program that tells the head how to move and how to, you know, overwrite symbols and whatnot. So, and what this thing is, it's a fundamental computational model, right? It's a fundamental computational model. So, and what's interesting is that everything you can compute in a modern computer, right? You can calculate in a modern computer. You can calculate in a Turing machine. So yeah. So it's sort of like a simplest fundamental computational model. That's what it is. And yeah, today we're gonna write an interpreter that, given the description of a Turing machine, will execute a Turing machine. Yeah. All right. So let's go. Let's create a folder called Turing. Right, I'm going to create the Turing, and I think I'm going to actually start tmux Turing, and maybe I need to go to my DMD distribution. It should be somewhere here. Should be somewhere here. Let me actually. There we go. So, sending Turing. There we go. So let's do dub init. Do I actually need to use dub? I don't plan to use any third-party dependency, so I might as well actually just, you know, have a main D in the root of my project and be done with it, and use makefiles to build this entire thing, because like, yeah, I think dub in this particular situation would be a huge overkill. Huge overkill. Std string. I'm not really sure if I need a std string. We will see. And let's do this kind of thing. All right. So write a len, and it's gonna be something like hello. It's a C++, by the way. We're using C++ today. All right, so let's create a makefile, because I mean, obviously, if I used D, I would use dub, right? Because who fucking uses makefiles when programming in D? It's 2020, just use dub. So this is C++. C++ doesn't have its own build tool or package manager, so that's why we have to rely on makefiles here. All right, so, and let's do DMD. All right, so let's try to do that. Like so, and it doesn't compile for some reason. So what did it say? I actually kind of missed it. No longer supported. Use OD. Okay, maybe not use this flag at all then. I haven't programmed in C++ for quite some time. I don't remember how to use its compiler. So it took some time actually. C++ became way slower than I remembered. So here it is. So we have a hello world, and we're ready to go. I wonder if it always creates this O file. You see, I don't quite remember creating this O file. So let me remove everything and double check that it's created by the current compilation line. Yeah, it always creates this O file. Which is kind of funny. All right, so let me do git ignore and ignore all of this stupid shit, right? Specifically O files, because who fucking uses O files in 2020? Who uses linkers in 2020? Oh my god! Just statically compile all of your executables like Go does, right? Go is a modern programming language, so yeah. All right. O files, more like boomer files. Got him. Anyway, so let's add readme. Readme and Turing Machine Interpreter. TMI. I think I should maybe call it TMI, Turing Machine Interpreter. Or maybe something like tumor. I think it's a good name for I think it's a pretty good name for a Turing machine interpreter, tumor. So all right. Jay the developer, thank you for 2 months of a tier 1 subscription. Thank you, and welcome back to our epic Turing machine club. How about that? To main, because you need. No, it's a little bit. Oh my god, I don't know how to use Vim. I don't understand how to use Vim. To main. What language we're using? C++ today. We're programming in C++. So okay, so it's gonna be just maybe TMI. TMI is already taken by Twitch stuff, I think. By Twitch stuff, but anyway. All right, so we're gonna have a quick start, and let's do the following thing. Is gonna be make, and then you're gonna do Turing, and that's gonna be it. And let me also add the Turing machine. Did I actually make the type? No, I didn't. You're debating me. Okay, MIT license. MIT license. Maybe I should call the call my interpreter MIT. You know, machine interpreter Turing. Turing machine compiler. Actually, sounds like a good idea. Wait a second. Wait a fucking second. That's a cool idea. No, it cannot. Thank you so much for 100 bits. So yeah, a Turing machine compiler is actually a pretty cool idea. I'll have to think about it. Thank you so much for 100 bits. Maybe that's exactly what we're gonna do. We can try to generate like assembly that actually executes this thing. Not a bad idea. Not a bad idea. I like it. Not a bad idea. License, and let's quickly prepare everything. 2020 copyright holder is some Russian dude. I don't know. Oh, the band compiler? What is that a term? Oh, the band. I never heard that term. That's a weird term. Is that like a computer science term, or what is it? I don't understand. So yeah, okay, so we have that, and I think we're ready to do git init. And let's add everything. Oh, the band is the okay. Okay, it's a nickname. I see. Ready, set, go, and let's put okay. And let's create a separate folder where we're gonna put all of that. Where are we gonna put all of that? God damn it, I fucking hate that it uses private by default, but I couldn't be bothered to go to settings and change it. And even check that it's possible to change it, because it was always public and they changed it one day, and now I fucking have to suffer. Alright, Turing machine interpreter. And let's create the repo. Add. Let's call it origin, I suppose. Let's push it by default. And let's push it. There you go. So now we have the repo here. Nice. So, and I'm gonna do a project. So here's the project, and I'm gonna do update CMD project. Today we're programming Turing machine, and I'm gonna give the link to the source code here. Right, I don't have any particular plan on what to do with the Turing machine. I'm just gonna go and implement the Turing machine interpreter, right? So that's the thing I'm gonna do. And then once we have this interpreter that can do something, maybe print something on the screen, and you know, farts and whistles, we can try to think of what exactly we can fart and whistle. Okay, so let's go. Something is terribly wrong with my dlang mod, and you know what's interesting is that it works perfectly on my other account. So maybe there's something wrong with my installation of Emacs here. So I have an interesting idea to try to remove Emacs Emacs.d and reinstall all of the packages from scratch. It will take a couple of minutes, but I think it will be worth it, because then I will be able to actually use Emacs for programming in D. Right. So I'm gonna actually reinstall everything super quick. I really apologize for the bright theme, but it is what it is. This is a naked Emacs. I might as well actually switch to a different tab. So in the meantime, you have a chance, boys and girls, to ask me any questions. In Makefile, what does DMD means? It's a C++ compiler. So there's a company that specializes on exactly. There's a company specializes on C++ compilers. The company is called Digital Mars. So, and one of their C++ compilers is DMD, right? So, and that's what we're using today. Because GCC and Clang are too mainstream for our hipster channel, so that's why we're using like a little bit less known C++ compilers. Digital Mars company. Yeah, it's a pretty cool compiler actually. I really enjoy it. Is it better to GCC and G++? You mean then? Yeah, of course it's better. Of course, because it's less known. Anything less known and less popular is better, right? Because there is less normies in the community. So the fewer amount of normies actually affects the quality dramatically. Trust me. What's your favorite letter? I don't know. Does anybody have any other questions while we're installing everything? So the best compilers out there are known to the public, right? That's exactly what they said. Can you make D++? What do you mean? What do you mean make? I don't understand. Microbic Music, thank you so much for 4 months of tier 1 subscription. Thank you, and welcome to our epic D club. I mean C++ club. I mean, we're programming in C++, not in D. Who would program in this hipster language that nobody uses? I mean, come on. So let's continue. Turing. So I think now it should kind of work. There you go. Now it works. So it was something with my Emacs installation or whatnot. So let me quickly check something. I remember there were problems with for each stuff. Okay, that's fucking perfect. I can finally use Emacs for D. Absolutely beautiful. Okay, so let's go to the Turing machine Wikipedia page. Why code this in exactly? That's exactly the question I'm asking. Like, why code this in D if you can code that in C++? And that's exactly what we're doing. We're coding it in C++. This is C++. So, like, why coding it in a hipster unknown language that literally nobody fucking uses if you can program that in C++ that everybody uses, and it's basically the programming language of planet Earth, right? So there's pretty much only a single programming language. Any other programming languages is just basically a constructs on top of C++, and C++ made it possible for these languages to exist. So there's basically only C++, right? So, and why would you use D, which is basically just a construct on C++, if you can just use C++? All right, so, and that's exactly what we're doing. We're using C++. A Turing machine is a mathematical model of computation that defines an abstract machine, blah, blah, blah. So that's actually pretty straightforward. And we have a bunch of pictures here. And here's, by the way, the state table for a busy Beaver. So here you go. So you have, if you have this symbol, the current symbol on the tape, and the current state of the head is A, right, that means you'll have to write symbol 1, move the tape to the right, and switch to the state B. That's exactly what you have to do. And that's exactly what we will try to encode here. So I'm gonna create like a data structure that, that basically encodes that, and then we'll write some code that interprets that thing. And of course, one of the important things as well is that you also have a hold state, right? You also have a hold state. So once you hit the hold state, the execution should stop. And we need to come up with the format for our machine that encodes that thing. So let me actually create something. Beaver. Let's create a file called Beaver, and let's give our Turing machine programs program files an extension called tur. Let's just quickly do that. So I think what we can do here is essentially, if you have a state A and you currently see a symbol 0, write 1, move to the right and switch to B. So we can try to encode this kind of table like this, right? We can try to encode this kind of table like this. Oh shit, okay, wait. This is fucking genius. Dude, you're a fucking genius. Yes. Jesus fucking Christ. Yes, it's gotta be called turd. Tune, all right. So how do I save that? Do I really scroll all the way to the fucking bottom? Did it? Okay, so I didn't see that button right away. So it's gonna be called turd. Thank you so much, by the way. Absolutely beautiful. Absolutely beautiful name, and we're gonna call it in D. Right, and I forgot to mention that this thing is participating in Hacktoberfest. Of course, everything is participating in Hacktoberfest. Hacktoberfest 2020, there we go. Turd, yeah. All right, so, and all of these things are going to be called turd files, I suppose. Oh my god, like we already have opened several files here. And let's quickly do that. So this one is going to be a turd file. It's going to be a turd file. And I might as well. So this is a main. I want to keep it named main. So, but how do you even do that? EMD. Do not write object files. Output. How do you specify the output file name in this stupid compiler? Like, Jesus Christ. Or you basically don't. I suppose you basically don't. OF? Oh, okay. Name output. I see. Okay. Thank you so much. So it's gonna be turd, and this one is OF. And we should be able to do this kind. And by the way, let's go to git ignore. So this one is turd, of course. And please tell me that it's gonna compile. And it doesn't fucking work because fuck me, of course. Argument expected for switch OF, and I provide you the argument. I don't know what kind of style of the argument providing it expects from me. Do you expect me to put equals there? Because I mean, I fucking hate it. Yeah, so like just support several styles. Like, why do you fucking force people particular fucking style? I don't know. Jesus fucking Christ. Like, all of this frustration is just not worth it. Okay, turd, whatever, just do that. All right, so I'm gonna go to the Beaver. So this is gonna be the format that we'll have to support. This is gonna be the format. Let me actually finish the Beaver thingy. Let me actually finish the Beaver thingy. Right, so, and in a state A, if you see 1, you write 1, you move to the left and you switch to C. There we go. So, yeah, essentially we encoded the whole thing here. Right, first is the current state and then what we see in that particular current state. And of course, we're going to support the spaces. So, because sometimes I want to separate. So, for example, here I'm going to have a block that is dedicated to state A, then I'm going to have a block that dedicated to state B, and then I'm going to have a block that dedicated to state C. All right, so, and here's an interesting thing. So then I'm going to say that if I see 0 in state B, I'm going to do one thing, and if I see 1 in state B, I'm going to see another thing, and similar thing here. Right, in case of 0, I'll have to write 1, move to the left and switch back to A. All right, so in case of 1, I have to switch to the right. Wait. I'll have to write 1, move to the right and stay at B. So this is how you encode loops in Turing machine, by the way. Right, this is the way to encode loops. At a particular state, you stay at the same state, and this entire thing sort of forms a loop. This is a simple loop, and this is the condition out of the loop. Right, you see, this is, yeah, basically a programming language. In case of a state 1, C, if you see 0, you write 1, move to the left and go to B, back to that loop. Then if you see 1, you go to the right, you write 1, go to the right, and then you halt. Okay. So here is an interesting thing. So our interpreter is gonna treat any state as a halting state that doesn't have a presence in any of these rows or in any of these instructions. You see, so A is present in these two instructions, B is present in these two instructions, and C is present in these two instructions. That's why A, B, and C are not halting states. Halt is not present in any of the instructions as the first one, so we're going to treat it as the halting state. And as a matter of fact, our interpreter should handle any kind of not handling state as the halting state. For example, hui, and hui is going to be halting state, but for the convenience, we're gonna just call it halt. All right, so we have a busy beaver. By the way, I assumed again that everybody knows what is a busy beaver. Does anybody know what is a busy beaver in the context of Turing machines? Does anybody know what it is? Like, it's sort of like a common puzzle game in Turing machine. So I don't remember exactly, but I think it has to feel everything was once or something. The busy beaver aims to find a terminating program of a given size that produces the most output possible. Okay. So yeah, more precise, the busy beaver consists of designing a halting binary alphabet Turing machine which writes the most once on the tape using only a given set of states. Yeah. So essentially, it's a terminated program of a fixed size that produces the maximum possible output. So yeah, people may we may use it as a testing program for our interpreter. So yeah, pretty much. So why does it say that I'm offline? Am I offline? Or is it something with Chatarina, or is it something with Twitch? That's really strange. It just literally says I'm offline. It's a Twitch bug. Okay, cool. All right, so let's try to read that file, right? Let's try to read that file. And the question is, how do you read files in D? I mean in C++, dlang read file. So there was a read text. Oh, there you go. Yeah, we have read text. I think I kind of remember it. Read text. Then I remember splitting everything by lines. Okay. So here we accept the arguments, right? So here are the arguments, and if arguments length, I think length is less than 2, we'll have to do the following thing. I kind of want to like just handle it without exceptions. I kind of want to handle that without any exceptions. So we're going to do write-ln, and I wonder if I can just do something like this: std_error write-ln, and then say input like error, right? So here's the error. Input file is not provided. Input file is not provided. Then std_error write-ln usage, and we're going to have a third. Input third, and then we're gonna actually return 1, indicating that you did a fucky wacky. Mr. Programmer, you did a fucky wacky, please fix. Ooh. Alright, so, and there we go, we're gonna do third, and as you can see, input file is not provided. We're gonna provide the Beaver third, and it says hello world. Absolutely beautiful. So we're gonna do a read text args 1, and I wonder what's gonna happen. So can I just write that file just to see what's gonna happen? Okay, so we don't have a read text, so I have to do std file, right? I have to import std file. And why does it take so much time? And after that, people say that decompiler is fast. Yeah, Beaver. There you go. It actually read the file. It actually read the file. All right. How can we split by lines? Can I do lines? Will it work? Will it do the thing? Okay. Std lines, this is not callable using arguments types. I think we already do something like that, but I forgot how we did that. Did we do that in the Pogtoberfest? I think we did that in Pogtoberfest, but again, I forgot already. I forgot everything. I'm so fucking old. I cannot remember shit. Yeah. There you go. So I don't think we split anything here. Yeah, we don't split anything here, unfortunately. Oh, okay, so we'll have to Google dlang split by lines. I'm pretty sure you can use split. Oh, there you go. There's a split lines, literally. Would you look at that? Would you look at that? Absolutely beautiful. All right, let's use that shit then. So it's located in std string. Import std string. There you go. There you go. So what was that? Split lines. Split lines. There we go. You're gonna work. You're gonna work now. It takes so much fucking time. It's unbelievable. Like the compilation times of D are actually quite bad compared to Go or C++. Seriously, I'm not even joking. All right, so there you go. We have lines here, and maybe one of the things I want to do is filter out empty lines. Right, because we don't really care about them. Like, we want to be able to ignore them. And another interesting thing, I'm gonna map everything, and quite importantly, I'm gonna strip everything. So I'm gonna remove trailing and leading white spaces, right? So then like later, I should be able to filter out everything that is empty. Where the length is greater than 0. Okay, so let's try to run that one more time. And it doesn't compile because why? I need to import algorithms. Cool, std algorithm. As to the algorithm C, or I have to put a semicolon there. Algorithm. Oh, there you go. Would you look at that? Isn't that beautiful? Isn't that mother flipping beautiful? I think it is. I think it's actually is. All right. So, and all right. And I'm gonna actually split everything like this, so it's a little bit easier to read. So you see, we initially just read the file, split by lines, strip each individual line, and then filter. I feel like I'm almost programming in Haskell, right? Only the language is better. So now I need a way to encode a single row here, right? So let's call this a single Turing machine instruction, right? So, so a single Turing machine instruction in our case is going to be called turd, right? So a single turd, yeah. So state. So we have a state, and then we're going to have a read symbol. Maybe I'm going to call it a read. After that, we have write, whatever you're supposed to write. Then you have direction, where to move. Maybe I'm going to call it step, right? I think that's going to be actually a good name for this enumeration. Is going to be step. And that step thingy is going to be either left or right. We might as well actually just call it L or R, right? So step L or R. And then we're going to have like a state to which you have to switch to, right? We have to use the state. So this is the current state. Maybe this is the next state. So, yep. You know what? I also want to have different aliases. You can use x.empty. Cool. Thank you so much. All right, so I want to have a bunch of aliases. So something like alias state, which is a string, and I'm not even sure if it's going to work like that. So is this how we do type aliases? Is this how we do type aliases in D? I have no idea. I'll have to Google that. Dlang type aliases. Alias this. I don't give a shit about articles. Alias type Golang. I like how fuck Google. Google wants to replace. Of course, Google wants to replace Dlang with Golang. Not biased at all, by the way. Okay, maybe that will yield something useful. Oh, for fuck's sake, Jesus Christ. Declarations, aliases. Why there's no link to the documentation? Why? This looks like a link to the documentation. Alias. Okay, cool. Alias declaration. Alright, so I can literally do like that. Cool. So another alias we're gonna have here is symbol, right? Symbol that you can write and read. And this is where we're gonna have the following thing. So we have a state. This is the current state. Okay, this is the current state, and this is the next state. Right. And these things are symbols. So this is a read symbol, and this is a write symbol. Right. So there we go. A single turd. A single turd. After that, I want to have a function that reads a single turd. I want to have a function that reads a single turd. Is there any way? Let's call it parse turd, and you accept a single string as, right? This is where we're going to do all of that. And after that, I'm going to do just map parse turd. Map parse turd. So in here, right? In here, we're gonna split everything by a white, so by white space. Printing third equals dumb. Ah, I see. Yeah, that's very funny. Yeah. It is in fact very funny. All right, so we also need to import something like std ASCII, and then so I also want to be able to print useful information, for example, where exactly fucky-wacky happened, but with this kind of approach, of course, we won't be able to do that. But we'll see. For example, we're definitely gonna have errors because, for example, what if you put incorrect name for a step, right? Left and right. So another interesting thing, is there any way to stay at the current thing? Blank simple input state. So relative uncommon variation low, no shift, say n. Relatively uncommon variation. So, but it's so that you can have like a third step, essentially no step, but that is considered non-traditional, right? A traditional Turing machine would have only left and right steps and no like n step. So okay, we're gonna go for traditional Turing machine then. I'm gonna go for the traditional Turing machine. Someone's calling me. I don't know that number, so I'm not gonna answer. So, oh, it's you. All right, that actually makes sense. My number leaked? Is that what happened? So the split. So we're gonna have like a 4 of them or something. I might as well actually for now return whatever we manage to split so we can see what's going on here. No, but IP leaked and Wi-Fi hacked. Yeah, god damn it, you hacked my Wi-Fi. All right, so missing argument string 43. I have to do it like that. I think that should be enough. As you can see, we managed to like split everything by words as well, right? We managed to split everything by words. And on top of that, I think it would be actually quite great to map everything with, you know, strip, right? So we're gonna map everything with strip. Just in case we're gonna have like additional spaces and whatnot. I'm not sure if we will, but I just want to make sure that everything's okay. So afterwards, after we stripped everything, we might as well. Yeah, we need to make sure that we have like 5 of the words, right? We have 5 of the words. So let's save that. So let's call these things tokens, right? I'm gonna call them tokens. Steven tokens. And I think I have to do something like array. There we go. So we have array, and I also need to import std array. There we go. And we're going to enforce a very important thing here. The size of the tokens, has to be equal 5, right? So it has to be equal 5. Now, we probably have to return some stuff. So if I create a third here, so the current has to be tokens 0, read tokens 1, write tokens 2, step. Okay, step 1 is interesting because it is enumeration, and I remember that you can parse enumeration, right? You can parse enumeration, and that was actually submitted by Travis, I think. To Oktoberfest. There we go. Something like parse. Yeah. Parse command. Yeah, so essentially you can just parse it. Do I need to import anything? Okay, I didn't think so. Let's just do parse. It's gonna be parse. Step. It's gonna be 3. Then third next is gonna be just simply tokens 4. And then we can return this third like that. All right. Dude, I like D language. He deals with memory language. Who are you talking about? And furthermore, we're not programming in D, we're programming in C++. All right. So let's try to build this entire stuff. Should be actually okay. And enforce, to use enforce, we have to use we have to import std exceptions. We have to import std exceptions. And it's std exception. It's a single one, it's a single exception. Template parse step template parse is not defined. What do I have to import then? Is it stdconv? Maybe stdconv. Import stdconv. This is a dude lang. Ah, you mean, okay, Jesus Christ, people. I was trying to make a joke about VLang, but I'm not gonna do that. Anyway, so okay, so as you can see, we have a bunch of turds, right? We have a bunch of turds that will represent the Turing machine. Yeah, it's pretty cool. It's pretty cool. So, but if you're gonna have like incorrect step here, right? If you're gonna have incorrect step here, you're gonna have a huge exception that doesn't tell you shit. It tells you step does not have a member named n, which is cool. But what if you have a very big file? You don't know where exactly a fakiwaki has happened. So you don't know where machine. Yes. You don't know where exactly a fakiwaki happened. So maybe this is what we want to focus on, to actually properly report where a parsing error has happened. So this is something that a lot of programmers don't give a shit about, right? So they just quickly hack together a simple parser without even concerning about properly handling and properly printing error messages. Which leads to like a very annoying user experience, because again, I made a typo in the file and I have no idea where I have to go to fix it. Like the program doesn't help me. So maybe this is something that I'm going to spend my time on trying to fix. So the Twitch says again that I'm offline. I don't know why, right? It's so weird. Twitch, like, can you just fix your shit already? The worst website I've ever seen in my life. Jesus fucking Christ. So, what's cool about... God damn it. So I'm thinking what will be the best way to achieve that. I don't see the stream in science and technology. I am in science and technology. Maybe because your streams are sorted according to recommendations or something. Or maybe it's just Twitch. I don't give a shit about all of that. I'm sorry. Couldn't be bothered. So what would be the best way to report errors? That's what I care about, though. I don't give a shit about crappy website that cannot fix itself with having multi-billion corporation behind it. What I do care is how I can make my software better. Right. So and for example, in WCC, it was super easy because I could just take the current token and subtract the beginning of the input from there, and I would get an offset super easily. But I'm not sure if I can do the same thing in D. Right. I'm not sure if I can do the same thing in D. Right. It would be cool if I could, but I don't know. So this is probably because I don't understand what is a string in D, right? I think I need a little bit more knowledge about what is a string. D-lang string. So what is a string exactly? Is this some sort of a class? What is it? Objects of type string, W string, D strings are value types and cannot be mutated element by element. Okay, that's actually pretty cool. So these are immutable strings. From using mutation during building strings, use char. Okay, that actually makes sense. The XXX strings types are preferable because they don't exhibit undesired aliasing, thus making code more robust. Undesired aliasing. Undesired aliasing. I have no idea what the fuck they're talking about, but okay. So can I take a look at the definition of string? Probably not. But yeah. From strings with Z at the end. All right. Cool. C style null terminated. You can do two strings. That is very interesting. That is very, very interesting. So we might try to use this kind of thing to get the offset of our token of our tokens in WCC style. I think that's what we're gonna do. I think that's a cool idea. I really like this idea, chat, by the way. I really like it. So let's just give it a try then. So, but to give that thing a try, I need to comment out everything super quick. And I'm gonna start with this. Right. I'm gonna start with this and let me run it one more time. All right. And in here, I think I'm gonna separate the content. So let's actually save the content somewhere here. So here is the content. Here's the content. So, and after that, what I want to do, I want to do a simple transformation, right? So I'm gonna do x to strings, right? And I'm gonna subtract content to strings, and I wonder if it will produce the desired results. That is very interesting, actually. That is very interesting. So let's go ahead and do that. Boom. It compiled and it did not produce any desired results, except, yeah, so that is, yeah, that is absolutely weird. So it has nothing to do with, you know, these things being relative to anything or whatever. All right. So it's just, it probably performs like arbitrary copying and stuff like that. It's probably all over the memory, so it's kind of pointless to even rely on that. It's cool that you can do that in C and C++, but in D you cannot use these kind of tricks. All right, one of the things we can use probably after splitting everything, we can try to enumerate this kind of stuff. But I'm not sure if there's like a special thing to enumerate. Like, can I do dlang enumerate? And let's see what's gonna happen here. Function enumerate. All right. Can you do something with enumerate? By line enumerate from 1. Apparently, I think you can. Okay, so we strip everything here, and then I do enumerate, and I have to provide probably the number from which I have to start. Okay, so I have to import std range. Why are you not highlighting that? Is it something wrong with Emacs? Cool. It is something wrong with Emacs. It is something wrong with Emacs, and yeah, so it actually returned a tuple, and on each tuple it has the number of the line, and we can use all of that to actually, you know, to then handle everything appropriately. Okay, cool. Why doesn't it color that properly? Revert buffer. Okay, everything's okay now. All right, so I'm totally fascinated of your Emacs skills. Haven't you thought about making stream series or YouTube playlist about how to master Emacs from 0 to hero? Or maybe it's too boring for you? It's not too boring for you. I don't think it's important. Just pick any editor and just use it. Editor does not make you a better software developer. It's just a tool. That's why I'm not doing that, because it's not important. If you think that's gonna help you somehow being better software development, you don't understand software development at all. You're moving in a completely wrong direction. Stop and think again what you're doing. It's not really boring, it's not important. No. So here we parse start, and I'm gonna enumerate after I did the filtering. So that's quite important. Enumerate 1. Enumerate 1. And you know what that means as well is that we'll have to kind of like do it like this, and I'm not sure if it's gonna work properly. It doesn't work properly, unfortunately. It does not work properly. And yeah, it's kind of sad. But we probably can actually extract tuples here right? So something like this, but I don't know the syntax of extracting the tuples. So dlang tuple. Right. For documentation on tuples that are commonly presented in other language, refer to Phobos documentations on tuple. You may also look into documentation for compile time sequences. It's moving around. Okay. Oh, okay. This is what we have here, and I need some examples. I think I saw some examples. Okay, so you can actually index them like this. Cool. So you can do that, which is absolutely beautiful. And I wonder how can I then refer to a tuple, right? So if I parse third, this one is going to be a tuple. Int like this, right? So here's s, and for example, if in any places here an error happens, yeah, we need to be able to properly report an error, and it's kind of annoying. But it is what it is. All right. So it's a parse third. So when I do s, I'm actually referring to this one. Doesn't compile. Is not defined, so that means I'll have to import type cons, right? Import std type cons. There we go. Can you just do that? Type cons. I'm getting annoyed by the language not being able. Okay, so this is actually okay. This is actually okay. Everything's okay here. So it's a completely different error. It's a completely different error. Okay, so we know the line, right? We know the line. On top of that, we may want to know the file path, right? So it's going to be file path. We might as well actually put it like that. So it's going to be the file path. And when I do it like that, so here's the X. I'm gonna do file path. File path is this thing. File path, X. There we go, there we go. We have a file fucking path. File fucking path. And if tokens length is not equal to 5, we're gonna throw an error saying something like this. File path, this thing, S0, right, S0, this thing, a single third, let's actually put it like that. A single third is expected to have 5 tokens. That's very fucking important, right? And I wish I could exit out of that like immediately, super easily, by doing something like 1. Maybe I will be able to do that. We'll see. We'll see. Okay, so now we have more or less like good error messaging, which is very important, in my opinion. All right, so if we can actually do switch. Let's quickly do switch. So here we do switch tokens 3. So this is the third token. And we're going to have a case here. So the first case is L. And in case of L, we just do something like step L. Right? So here is the break, and the next one is going to be R. So third step R. and then we're going to break. And in case of a default situation, we are about to complain that at a file path at the S0 line, we got an expected step. So let's do something like this. Tokens 3 is not a correct step, right? Expected L or R. See, we do care about user experience. We not only tell the user that you provided incorrect step, we also tell you what are expected steps. See, it's quite convenient. It's quite fucking convenient, mate. Super fucking convenient. So what else do we need here? I'm not quite sure. You know what I would like to also do? I want to introduce a couple of like const expressions of a sort. Something like, I think it's usually used immutable in D at least. Immutable, right? It's going to be int tokens current, right? Tokens current, and then we can have tokens read, tokens write, tokens step, and tokens next. And for in each individual one of them, we're gonna store the index, right? We're gonna store the index, so we can get rid of these magical numbers here, right? Something like tokens current. And since they are inside of this function, maybe there's no need to prefix them, right? Like there's no need to prefix them at all. We can just keep them like that. So this one is a current, this one is read, this one is write, this one is step. Look at that, like tokens current, tokens read, tokens write, and then like tokens next. And here we have steps, so you're never gonna make like a mistake here like that. So might as well also have similar things here for this input, right? But I'm not sure. It would be better if this tuple was, to be fair, look at that. Where is the tuples? I remember tuples were kind of interesting. Okay, so I'm gonna try to find them. Tuple. Let's find the tuples that could be relevant for us. Look at that. What is this? What is this? Does that mean that to access the corresponding fields of the tuple, I might use these names instead of numbers? That is actually pretty cool if I can. Let's find out. So I'm going to try to actually use this type. So this is something that I instantly noticed, but I actually put it at the back of my head. Right, and so I think the time has come to give it a try. Lambakota, we have a professional D developer in the chat. Mein Gott, welcome to the streamos. How are you fucking doing? Really glad to see you. Alright, so let's go. Actual professional D developer. Alright. So in here, I suppose I should be able to do the following thing. So this one is a value, maybe, and maybe that one is going to be an index. But I'm not sure. I'm not sure. Corona, by the way. So let's try to build this kind of shit. And it doesn't fucking compile. Implicitly convert expression value of type to ulong. God fucking damn it, but I wonder if I can do something like instead of that. Since it's a compiled some value, maybe it generates something like this. Oh shit! shit. Oh shit. The fuck? The fuck you said to me, you little shit? Bruh. Bruh. Look at that, it actually works. It actually works. Alright. I ran out of water, by the way, so. Okay, so that's pretty convenient, I gotta say. So we have a parser. Then we're supposed to return just third, right? Okay, cool. Now I'm going to try to not only run that, but I'm going to run that from within Emacs to indicate the beautifulness of this solution. I cannot do that easily. I have to actually run Emacs from within the development environment. I think it reminds me of my NixOS times, you know, development environments and running Emacs from within the development environments and shit. That were the beautiful times. Okay. Show me what you've got. All right, so it still uses that weird thing. Do I still use parse? Dude, what the fuck? Did I not recompile that properly? Why is it still using like an old version or something? N is not correct step expected. Okay. So, do we have like a right len that... Right. Okay, let's give it a try. Okay, so let's create the following thing. We're gonna have thirds. Outer thirds. So here are the thirds, and only then we're gonna try to print those thirds. There we go. So we're gonna first try to compile all of them, and only then... Why are you printing them? Because it's lazy. So I probably have to do something like array, right? To make it, to force it. Man, I didn't expect to actually have laziness problem. Okay, so look at that, chat, look at that. It actually tells me where exactly the error has happened. That's why I'm spending so much time. Look, it tells you. I understand that 99.999% of developers don't give a shit. They just throw their turds together and call it a program. But I do care about user experience. All right? And it's very fucking important. If you don't care about user experience, you end up with your program being a piece of shit. All right. So, okay, so we have a B, and this one has to be actually R. This one has to be actually R. All right. And as you can see, everything works. But if you, again, do like something incorrect here, you're going to end up with error. And yeah, that would go. So I wonder, how can I exit with, you know, exit with a non-zero exit code, but without assertion and fat ass, you know, stack trace that nobody gives a shit about. dlang exit, not dang, dlang exit. All right, let's try to do that. Maybe that's gonna be useful. I don't fucking know. I don't really like the huge reliance of D on exceptions and stuff like that. It's kind of annoying. But I suppose it is what it is. Yeah. It is what it is, and it isn't what it isn't. There we go. Just don't use exceptions. Like everything in standard library uses exceptions. By using standard library, you're by definition using exceptions. There's nothing you can do about that. Okay, so we finally managed to have a decent third parsing. I'm super proud of myself. So now we need to interpret this motherfuckers. Wait a second. exit. Did I even use? What the fuck is wrong with me, by the way? I think I'm going crazy. Alright, cool. Assert doesn't throw exceptions though. The fuck is this shit though? Or is it not an exception? So it throws error. Oh, it's yet another. Oh my god, it's yet another language with this bullshit of exceptions versus errors. It's different mechanisms. I'm so fucking sick of this shit. Okay, let's make a small break. Oh my god, I'm so tired of this bullshit. Like, I tried so many languages, and in each individual one of them, it's just, fuck's sake. Just make a fucking normal language already. Alright. So, pretzel rocks. Do you guys like chiptune, by the way? Mm, 2 minutes? Yeah, I think 2 minutes is gonna be okay. Let's make some break, and you guys have fun. Hey yo, welcome back to back. How is everyone doing? How is everyone doing? Welcome, welcome. Okay, so now I think I need to start interpreting all this. Hello, Master Baition. Welcome. Let me take the machine. So let's introduce the machine, right? Third machine. It has a tape, right? And the tape is gonna store the current symbol, right? So it's basically the tape of symbols, and it's gonna be a dynamic array. I don't know how to use dynamic arrays in D yet, but I suppose we're gonna actually learn that a little bit later. Now we need to have a head. Maybe yeah, it's gonna be something like head. Oh yeah, it's a part of the type. Yeah, thank you so much. That explains that the highlighting wasn't correct. So, and we're also going to have the current state. And I wonder what's the initial state though? What's the initial state? That's a good question. Maybe we're going to have some sort of a convention that the state, the initial state of the program is the state of the first third. So basically, yeah. So it looks at the first third, and this is the initial state of the program. Yeah. All right, so here's the head, and then we're going to have a state. There we go. Cool. Next thing. We need a method that calculates the next state of the machine. Right. Something that calculates the next state of the machine, and what's interesting is that it should accept a program. Right, a program. And program is a bunch of thirds. Right, program is going to be a bunch of thirds, and I'm not even sure if it's a good idea to make an alias of program third. We'll see, maybe. Let's actually not do that, and I'm going to just simply accept a bunch of thirds. There we go. And maybe this thing will indicate a termination, right? So we might as well actually return like a boolean. So if it's, you know, if it's a return true or false, that means the time to terminate. I would let the user explicitly the initial state and the tape input. That's actually a good idea. So it could not, it may not necessarily have to be the it could be a convention of some sort as well. I don't know. Yeah, all right. We may go with that idea. All right. So we read a bunch of thirds. And now I need to construct a machine. I suppose this entire thing is going to be like this. It's going to be like 0 initialized by default. All right. While machine next, we may want to actually dump the state of the machine, right? We're going to dump a state of the machine, and it's going to be yet another method here. Void dump, and I wonder what exactly we're going to put there, and where we're going to accept the initial state. Maybe we're going to accept it here, right? So this is going to be like that, initial state. So this one is going to be 3. So here's a file path, and initial state is going to be RGS2, right? And here machine state. I said state, please. Initial state. So let's try to build that thing and see if it builds itself. It doesn't build because why? Missing argument for parameter. Oh, okay. So we'll have to actually, you know, pass the thirds here. There we go. Don't forget to pass the thirds. Dude, I'm not programming in some JavaScript. I'm programming in a statically compiled language that tells me if I forget to pass an argument to a function. Right. So that illuminates the whole class of problems that you don't have to think about at all. Like it's not a problem, non-existent problem. Okay. What about passing Turing machine in the Turing machine? It's called universal Turing machine. You can Google that. So I need to remove this thing by the way. So we're gonna dump here. I think I'm gonna just dump the tape. And yeah. I remember somebody telling me it is not a problem in interpreted languages too. All you have to do is write unit tests that check the right args. Yeah, it's a kind of stupid arguments because in statically typed languages you just don't have to do that. Like, just don't have to do that. But you know, there's a counter argument to that because you need to write tests anyway. You need to write tests anyway, so might as well actually. But I mean, yeah, the amount of tests you have to write is actually enormous if you don't have the static language. Have you seen the implementation of isArray? It's fucking insane. So, or isNumber, or something like that. It's just, and all right. And the argument that you need to write tests anyway is kind of interesting. What if you don't? Why write tests at all? Because, for example, Yegor Bugayenko actually has like a pretty good example. There's a website, booking.com, right? So they don't write unit tests or any kind of testings at all, like at all. They even explicitly tell their developers to not test their changes completely. What they do essentially every month they allocate like several millions of dollars for refunds due to errors in the code. So I'm not even fucking joking. That's the example. So essentially, the company found that it's just cheaper to refund money to the users than write tests. It's fucking cheaper. And the market has decided that. Like they just sat with the calculator and calculated, okay, it would be just cheaper to do that. And they did it. Do you need to write tests? It depends. I don't know. Depends on your situation. It's actually a very good example, by the way. It's a super cool example. It actually turned out cheaper for them, for their particular situation. All right. Now. I forgot what I was doing actually. And yeah, users essentially you're paying users for testing at this point. Reminds me of electronics chains store in my country where they hire the worst, cheapest courier they should find, and when package go missing, they just refund the client. Yeah, it's kind of similar situation actually. It's a very similar situation. Who fucking needs quality? All right. If the market needed quality, maybe I would have a job. So, haha, I'm so humble, by the way. All right. So what I'm gonna do? I need to iterate through each and individual program. Right? So it's going to be a third program. If third state, is it state? It's current, yes. Third current equal state and third read equal tape head. You see, so here's the current state. And here is the current thing. And in this particular situation, what we're doing, we're supposed to write third right, and then we're supposed to step the head, and this is what we're going to do. It's going to be final switch third step, step left, so this is the first one, step right, tape. So if it's gonna be left, it's gonna be -1. If it's gonna be right, it's gonna be +1, right? So, and then the state of the program, the kind of state of the program is going to be next. There you go. So this is the simple interpreter. And once you found that, we might as well actually return true, meaning that you still have to continue. Otherwise, if we never actually found any of these combinations, we found the halting state, so we have to halt. So yeah, that's actually pretty cool. What's going to be a dump? Dump is essentially going to be iterating through all of the tapes, I suppose. So we don't handle the situation of growing the tape, right? So we don't handle the situation of growing the tape. How are we going to grow it though? Do we? It's a good question. Maybe we're gonna fill it with something. Maybe it's not gonna be infinite. Maybe it's gonna be set up on main. Maybe it's gonna be set up on main. So I'm gonna iterate through all of the cells. So cell tape, and we're gonna just simply do right ln cell. There we go. It's actually not right ln, it's just right. Right, it's going to be right ln, and that should be okay. Let's do a compilation. Let's do a compilation. So compilation went well. All right. So the only thing we need to do now is I'm just thinking, just populate the tape. We just need to populate the tape, but the question is, where are we gonna populate the tape? Also, I want to actually execute everything in sort of like a step debugging fashion. And maybe we're going to accept the tape in the as a separate file, right? So here's the input third, and we're going to have an input tape, right? So this is the input tape. So let's actually have a tape that consists of zeros. Right. So here is simply a tape that consists of zeros. So this is the bunch of zeros. And in here, okay, so that means we'll have to have this here. So file path query replace file path, and it's going to be not file path, but actually third file path. There we go. So here's the third file path. Then we have tape file path. So this is 2 and this is 3. Okay, and here is going to be a machine tape, read text, tape file path, split is white, map strip. There we go. So this is going to be the tape. So we're literally reading the tape from a separate file. All right, and it doesn't compile properly because why? Because this thing has to be for each. I see. Semicolon expected. Forgot the semicolon, and still doesn't properly compile because tape. This one is a head. I see. This one is a head. All right. Cannot implicitly convert. So this thing has to be an array, and cool. We build it. We fucking build it. Oh my god. So when I dump thing, I think it's not particularly great idea to just dump it because it doesn't indicate where the head is located, right? So that could be a problem. So here's the idea: we're gonna print the tape, and then we're gonna print yet another thing here. So for each cell tape, one more time, right? And so I'm gonna print the amount of spaces as the size of the cell, right? So cell length plus I, and what I'm doing here, I'm just writing the spaces, and after that I write yet another space. And maybe here I also want to have like I here, so which by the way means that this has to be a J, right? It has to be a J, and let me think. If this one is interesting. If I is equal head, that means we'll have to do a very interesting thing actually. My brain doesn't want to work. Well, that means we'll have to write this thing like that, but on top of that we shouldn't write this thing because it should have to be a little bit shorter, right? Something like this, right? Something like this, because it has to be slightly shorter. Does it make any sense? I think it can make sense, maybe just a little bit. Right, so basically we're trying to draw the cursor that points at the current cell in the machine or something. Right, hopefully that will make sense once we're done. Okay, so let's actually try to run it and see what's going to happen. Yeah, we have to properly do that. So we already have input for the tape, input tape, and what's going to be the initial state? The initial state is going to be A. There we go. So it already computed something. So I suppose every time I press space, it should, you know, go to the next state. But there is some problems here. There are some problems here. I think we should try to dump the machine first. Right, we should just dump the machine first. Dump the machine first, wait, and only then go to the next, and so on and so forth. Is there like a do while? I'm pretty sure there's a do while. It's actually pretty cool. This could be one of the rare cases when you kind of need do while, don't you think? Right? Because I want to show the current state of the machine and the wait before trying to calculate the next thing. Right, so this is one of the rare cases when you need do while. And yeah. So, and that actually, yeah, that's the whole thing. So do while. Yeah, that's actually very cool. Yeah. Just people don't make anything, you know, sophisticated anymore, and that's why they think they don't need do while. Why no repeat until? Oh yeah, I fucking hate repeat until. All right. So the question is, why does it go? Am I doing everything correctly? So left. Okay, head is initially going to be 0, right? Head is initially going to be 0, so I might as well actually, you know, initialize it from scratch. Oh, we have a rate. Hello, Donho. Thank you for the rate. So here's the initial state, blah blah blah, and everything seems to be okay. everything seems to be okay. And I suppose what I need here is actually recompile everything. All right, so here's the initial state, and here we have that. And for some reason then it goes back, and I'm not sure why. And then it tries to, yeah, I suppose we may try to wrap that shit around. How about that? We may, okay, so let's try to wrap that shit around and see what's gonna happen. So it's gonna be, where is it? I didn't see it. Here it is. So do we have, I think we don't have a correct modular there. So that means we'll have to do it like that. Tape length. Punch card stream is getting closer. So so we're gonna have a problem for negative numbers. So you cannot just do negative numbers like that, right? So we'll have to do slightly differently. So if head is equals 0, right? So head is gonna be equal tape -1, otherwise it's gonna be just head -1. This is going to be head -1, and let's try to compile that. It doesn't compile because why? So the length is actually u long. Okay, so we might as well make this thing u long as well. I don't mind that. I don't mind that at all. Okay, let's actually try to run that and let's see what's going to happen. So here's the busy beaver. For some reason, it goes to the right and then it tries to go to the left. I suspect that maybe it goes to the right until it sees 0, right, and then goes to the left until it sees 0, and then it goes to the right and basically fill everything like with ones left to right. Let's actually check that assumption. All right, so we see it sees 0, it puts 1 and goes to the left, sets 1. That was actually kind of interesting, but yeah, it goes left and right, and at some particular point it stops. But yeah, I suppose there's like a limitation of how many steps you can make. Yeah, it's kind of interesting. Let me double check if I copied busy beaver correctly. Maybe I actually didn't copy it correctly. That could be the case as well. That could be the case as well. Busy beaver. So here's the state A, 0. 1 RB, 1 LC. Okay, makes sense. B, 0 is 1 LA, 1 RB. Makes sense. 0, 1 LB, 1 R halt. All right, that's cool. That is super cool. That is super cool. I wish there was like a way to set the initial position of the head, because why not? All right. So also we probably need to know the current state of the machine. Where is the dump? Where is the dump? So it's going to be something like write-ln state. And we're gonna just put state here, and now next time we'll do something like this. Yeah, as you can see, we have state A. Now we're in state B, and then in state A yet again, in state C, in state B, and yeah, then yeah, and at some point we stop. All right, so let's actually maybe write, our own program that does something, right? How about the following thing? So we're gonna, so here's the input, just arbitrary input, right? So let's actually call it input 01. Let's introduce another input, input 02, right? So we're gonna have like a bunch of zeros here, right? And then we're gonna have 1. And let's write a simple program that goes to the right and fills everything with ones until it sees 1. Should be pretty straightforward. So let's call it filler turd. So it's gonna have like a bunch of states. Maybe it's gonna have like a single state, right? So let's call this state filler. So initial state is a filler, right? And when you are in a filler state and you see a 0, what you're doing, you write 1, you move to the right, and you stay in a filler state. So this is how we organized a simple loop. If you're in a filler, stay in a filler, right? If you are in a filler but you see 1, you write 1 because you don't have an option to not write. So this is something interesting about Turing machine. You always have to write something down. You don't have an option to not write. And if you don't want to write something, write the same symbol there. Then maybe you can move to the right as well. Again, we don't have, in a traditional Turing machine, we don't have an option to not move, right? So there's modifications where you also have n not to move, but we're doing traditional thing, right? And then I'm gonna do halt. There you go. This is how easily you can write a simple program that fills all of the zeros with ones until it sees 1, and then it stops. So it's just 2 third instructions. It's just 2 third instructions. All right, so let's see what we can do here. So here we're gonna use a filler. Then we're gonna use input 02, I suppose. Yes, it is 02. I need to save that first. And the initial state is gonna be filler state. All right, so let's see. We are in a filler state. The next one is this. Boom, 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 boom. Still working. What's interesting is that when we go to the halt, right, only on the next iteration we're gonna stop, right? But overall, it works exactly as we intended. And this is the Turing machine. Seriously, it's as simple as that. And programming this machine is relatively easy, as you can see. Right, so you need to check your current state, right? Then what is the currently written in a cell, and just rewrite to something else and move left or right. Yeah, so that's what we have here. It's a simple state machine. It's a simple state machine. Okay. That's pretty cool. That's pretty cool. I really like what I see here. So I also want to be able to set the current position of the head. That will be very interesting. But where are we going to do that? So the input, command line input becomes sort of like complicated. Maybe I want to change something. I have an interesting idea. What if we ask initial state interactively? Right, so basically you start the program, it says what's going to be the initial state, and it also presents to you all of the possible states of the program, right? It basically goes through all of the thirds, right? Goes through all of the thirds, looks at the current and next, accumulates them in a sets, and presents to you, here are the possible states of that machine. Which one do you want to start with? So sounds like a good idea, actually. Really like that. So before we go there, let's actually commit everything we have. So we have a bunch of like thirds and tapes. So let's actually put them like that. So here are thirds, and we're gonna put them here. And then we're gonna have tapes in thirds. Oh my god, I just realized that it's a parasite joke. Who would have thought? Like, you have tapes in your third. What the fuck? I didn't think about that. Sorry. It was completely unintentional. I didn't think it's gonna happen. But third stands for Turing machine in D. That's what it stands for. I need a little bit more water, I'm sorry. So third, so first we have to provide thirds, filler, third, then tapes, input 0 to tape, and then we're going to provide the filler. Here's the interesting thing. I think the state should be case insensitive, or maybe it should not be. It's kind of hard to tell. All right. Yep. All right. Implement simple. Did I add? Whatever. Thank you. Implement simple Turing machine interpreter to the simple Turing machine interpreter, and I'm going to push that right into the repo. Right, so you can find the source code of the thing that we're developing here here in the chat by doing project command or today command. Does it still say Turing? But it should actually redirect. Yes, it automatically redirects to third. So we might as well wanna take this thing. I'm a little bit tired already. For some reason I cannot copy paste that thing. I think I can. Oh my god. Chatterina is being difficult today. And what I wanted, update CMD project. I wanted to replace this thing with third. All right. I think I need to make a small break. Yeah, let's make a small break. All right, let's make a small break and you guys have fun. All right, I'm back. Let's continue. So I have a lot of ideas that I need to implement here, but I need to start organizing them. All right, so everything is here. right? Everything seems to be okie dokie. But I forgot what I wanted to do here. We need a way to set the head, right? Way to set the initial position of the head. So this is one of the things I wanted to do. Then maybe we can also set the head interactively. Essentially by not typing the number though, but actually selecting left and right the corresponding cell where you want to start. That will be actually pretty cool, I think. That will be actually pretty cool. Interactively select initial state. Interactively select initial state. Maybe I want to make the state case insensitive. Maybe I do not. Maybe it doesn't matter. Maybe it doesn't matter. Way to set the initial position of the head. All right, so let's actually start with initial state. So we need a function that will return us all of the states that we have in the thirds. Right, so how can we do that? Maybe we can put all of these states that we see in the thirds, states of thirds. So here we accept the thirds. We can put them into a set. Do we have any sets in the dlang? Dlang sets. How to work with sets in dlang? So there's a set ops, containers, and sets something like I just want to collect everything in sets. Or maybe there is a way to sort everything. And then remove duplicates, right? And maybe then remove duplicates. But maybe not. Okay, so set primitive sets. Adding sets to the language. Did they add them though? The discussion was 5 years ago. Did they add them? I have no idea. Maybe they did, maybe they did not. All right, maybe we should call them hash sets because it may not understand what exactly I'm talking about. Memory efficient hash sets. All right, memory efficient hash sets. So they refer to some sort of third-party dependencies, right? They refer to some sort of third-party dependencies. Okay. That is actually very fucking sad. Like, what the fuck is going on? So, containers. My assumption is that maybe inside of containers we're gonna have something. So, std array, dlist, slist, binary. What is that? Okay, so, oh my god, it's jumping around. It's so bad. I'm tired of this shit. Oh, Jesus Christ. Hate it. Like, I hate the websites when you click something, it's the markup starts jumping around. It's so annoying. Containers. And I lost containers. Okay, fuck this shit. I'm so fucking tired. So I'm gonna organize that. I might as well actually push them to the array, sort them, and remove duplicates of some sort. That could be also a thing, actually. It's so dumb. Oh, by the way, I just realized that maybe I can do DMD one more time. DMD. Phobos, right? Probably Phobos. std container. What is dlist? The fuck is dlist? The double linked list. Jesus Christ! Can't you just call it double linked list or something? S list. What the fuck is S list? Singly linked list. Arbitrary. Okay. So, and all of that is maps, right? All of that shit is maps. And algorithms. So there's a comparison mutation. Duplicates. Do you have an algorithm that removes duplicates? Iteration. Okay. Grep rn unique. Thank you so much. Jesus fucking Christ. Like different languages call the same shit differently, and it's such a fucking hassle every fucking time to learn what do they call that specific thing in that language, right? So it's like the whole investigation, right? So you have to find the author of the library. Then you have to go and find what university they finished and what kind of teachers they had and what kind of books they read and what kind of languages they used. And then through a detective work, you can figure out how exactly they called that concept in that language, because none of these concepts are fucking standardized anywhere. Right, and it all depends on where a person actually got an education, what kind of shit they read, or whatever. Like, so fucking annoying. Why do we have so many languages? We need to have like a one single language. Okay, iterates over unique elements in a range which assumes sorted. Okay, so this is probably one of the things we can do. I'm so fucking tired. Okay, so dynamic arrays, right? Dynamic arrays. Maybe we don't need that. Actually, I have an interesting idea. For fuck's sake. Okay, turds. Right. So I'm gonna start iterating this shit. What I want to map them with, is there any way to do concat map in dlang? I forgot to type it. Quicksort concat map. Wait a second. This concat map. So probably maybe there is like a concat of arrays. Concat slices, maybe. Chain. It's not going to be concat map though. Why people write me? Spread? What the fuck is spread? I cannot continue. I cannot continue. Like I'm trying to force myself to continue this program. I cannot. I cannot do that. What the fuck? I need to make a simple thing. I cannot do that. I'm so tired. Is there any way to actually disable all of the highlights in Arena? I wonder. Okay. So here's the third file. So we have all the thirds here, right? So this one is going to be 0, return 0. Okay, let's try to sort them. I swear to God, if because of this is not gonna compile, I'm gonna be I don't know what I'm gonna be. It doesn't matter. Yeah, it's probably not because of that, because you have to do something like a slash something stupid as that. Like I don't remember. Like it's so dumb. Needs to member compare. What do they want from me? So can you not? I just want to test things. Okay. So can you remove this thing like that? Can you remove like that? All right. You can. It's not callable using arguments types. I wish at least it fucking prints something reasonable. It's fucking prints like sometimes it's worse than C++ fucking template shit. Okay. Alright. Defined and for fuck's sake. And now I have to comment it out. Fucking comment it out just to fucking compile this shit. Finally made it compilable, so now I can focus on experimenting with the thing. So after I'm done with experiment, I'll have to bring it back again. So now, can I sort it now? That's a good question. Can I sort it now? All right, so let's give it a try. And I don't remember if I need to do it like that. Thirds needs to implement. Okay, whatever then. I need to map them to a sequence of these things, but I'm not sure if I can flatten that sequence, unfortunately. So because in here I can take a third. So here's the current state, and then I have the next state. And I remember dlang had like a compile time sequences. Compile time sequence. Some sort of a compile time sequence, and maybe that's a thing that I will need here. What is that? So this is alias sequence or something. Okay, is there something for ranges? A dlang range. So there are ranges, because I want to be able to flatten that out. So ranges into 0, 1. What is the way to create a new range? How do you create a new range? Okay, is there so there's a chain. Okay, that's understandable. Wait. So we can do T filter map. That is cool. Stride. Okay. Push to dynamic array. How do you push to dynamic array? How do you remove insert elements in dynamic array? Append. You can only append another dynamic array to. What's a nice language? Assume safe append. What? I need an experiment. I need to conduct an. Oh my god, I haven't saved shit here. That's enough for me. That's the only thing I want. Fuck all of that stupid shit. So waste of time. Okay. States of turds. And we're gonna have a bunch of states here, right? So here are the states. Current. Next. Sort. Remember that you have to do this stupid shit, but I don't remember why. Sort unique array. So that's the only thing I want here. I'm compiling the wrong thing, by the way. Alright, so make minus b. No property current, because... Yeah, I could have actually just used for each. I think I could have just used for each. Define state. States. Okay, finally, Jesus fucking Christ. All right, so and now we can try to, once we actually read all of them, we can try to print them. For each states of that shit. I probably need to do for each. Right, this has to be like this. Right align state. Should probably take 2 days off, 3 more days off. Okay, where is my Emacs? Okay, this. Alright. What the fuck is this shit? Alright, so it has to be thirds. Autocompletes this shit already. Oh my god. Are you gonna autocomplete it? Okay, thank you. Finally. Okay, I just want to see if it's gonna. Okay, so here are the possible states. If I switch to Beaver, the possible states are going to be A, B, C, and hold. Finally, we have that. We have that. So what if we do not provide the initial state? Here is going to be just 3. Remove that. Initial state. All right. And this is what we can do here. Write ln possible states. Right in here, we're gonna actually pad all of that with a couple of spaces. And maybe then we're gonna do something like write initial state. So we're gonna prompt that. Do I have initial state anywhere? So I have it here. So I should be able to do the following thing where I do auto read ln. And we're going to do stripe. Yeah, I think this is the stripe. So this is how we're going to do all of that. Look. So I'm going to do that. And possible states, initial state, filler. Right, and we're starting this kind of stuff. So if you do Beaver, well, that was actually a mistake. That's where you're supposed to have that, right? So I put A here, and we start with the A, and we're starting to move around. So yeah, this is basically how we're going to do that. All right, so let's do a commit and commit all of that. So I'll probably have to remove this thing here. Right, I'll probably have to remove this thing here, and let me remove this kind of stuff. Select initial state interactively. Right, select initial state interactively. And do I need anything else? Do I really care about initial state of the head? I kind of want to. I want to be able to just look at the state of the thing. And do left and right and select the head. I think that would be actually pretty cool. We can do that with escape codes of the terminal without using any stupid incursors and shit. But it will probably require like handling. What if the tape is too huge, right? What if the tape is too huge? What are we gonna do about that? I don't know. So maybe I'm not going to do that. So maybe we're going to assume that the initial state is 0, or maybe the tape itself, but it would be kind of bad to, you know, assume that the tape itself should provide the partition. Okay, whatever. One of the things I wanted to implement, I just got an idea. Let's implement a thing that increments a number. Right, that would be actually pretty cool. Let's implement like a number incrementer. Very interesting. So essentially, let's create inc_third. Right, so here's the inc_third. And here we're gonna have tapes. And let's put something in a tape 3. We're gonna have like... What the fuck are you doing? What the hell is going on? Oh my god. 0, 0, 0, 0, like, and 1. So essentially, it's actually super simple. Look, if you encounter 0, you just increment and stop. Right. But if you encounter 1, you replace it with 0, move to the right, and repeat that stuff until you encounter 0. Right? So, because look at that. So to increment... Oh, by the way, it's kind of, I forgot to mention. Least significant numbers are going first, right? So usually we're using Arabic numbers where the least significant numbers are to the right. So for this particular thing, we're gonna have like least significant one at the left because it's a little bit easier to implement it like that. Right. Now, so essentially, if you have ones here, what you have to do is to fill all of the ones with zeros, and once you encounter 0, just put 1. This is how you increment. So let's try to put that in practice. Let's try to implement that. So we're gonna have a state A. So in your initial state A is gonna be the loop, right? So if you encounter 0, you write 1, move to the left or right, doesn't matter, we're gonna move to the right, and then we halt. That means we did our job well, right? So yeah, then if we encounter 1, we fill it with 0, move to the right, and continue doing that until we hit 0, and that should be it. Right, so that's a simple program that increments a binary number. Right, it's pretty straightforward. Pretty straightforward. Let's give it a try. Let's give it a try. So it's gonna be third. The input is gonna be third's increment, then tape input 0, 3. So and the initial state is gonna be A. And there we go. So we're in state A. As you can see, we fill in everything with zeros, then we see 1, and then we halt. As you can see, this was the original number, and then we incremented it. There we go. There we go. It's pretty straightforward. It would be actually very interesting to keep incrementing the number. What do you guys think? Like, keep incrementing it. So here's an idea. We're going to, so it's a single increment. Let's introduce another one, counter. Let's call it counter, and the counter is gonna indefinitely increment the number, right? So that's gonna be the idea. Just indefinitely increment the number, or until you ran out of tape. Essentially, you're gonna have this thing. Maybe we're gonna put it like that. So you increment the number, boom, 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 and now you need to go back to reset the algorithm, right? You need to go back to reset the algorithm, but how can you go back? How do you know when to stop, right? We might want to introduce a special marker, right? I don't know, we may call it something like this. This is going to indicate the beginning of the number, where the number starts. Right. So essentially, once you finish the increment, we're going to go to the state that goes to the left until it sees the marker, then goes to the right and repeats the process. Right. I don't know what we can use as a marker. Let's actually use this like a star as a marker. I think it's a pretty good marker. Right. So this is going to be our input. It needs like this marker to keep incrementing things. So let's see how we can implement that. That would be actually very interesting. I just realized that I never implemented anything like that. By the way, this is a tape. This is a tape. This is not what I want. So this one is going to be input 04 tape. So here's our tape. And symbols, by the way, symbols can be anything, right? Symbols can be absolutely anything. They do not necessarily have to be zeros or ones. We use zeros or ones because, you know, just for demonstration purposes. But again, I can just put this thing here and yeah, any symbol, and we can use it as a marker again. All right, so here's the counter third, and we're gonna start. Oh, this one is interesting. So since we cannot set the head, we have to do something here. I think it's not a valid cron. Very funny. Thank you so much. All right, so we're gonna start with begin. So in the begin, we expect this thing to have that, right? Then if we see that thing, we write that thing back, move to the right, and switch to increment algorithm. So if we encounter anything else, we're gonna immediately stop. That means we got incorrect input, right? So what is the increment algorithm? Increment algorithm is actually whatever you saw in the ink here. It's that one. If you see 0, you just write 1, move to the left, and you initiate back sequence. So this is the sequence where you'll have to go back until you see this marker, right? If you see 1, you replace it with 0. By the way, you have to, well, we'll see. You replace it with 0, then you go to the right and you repeat. All right, so here's the increment loop that makes one single increment. Now we need to do a back sequence. So back, if you being in back encounter the marker, you just write the marker back, go to the right, and initiate the increment sequence, right? If you encounter anything else, either 0 or 1, you just write them back, keep going to the left in the same loop. Here it is. Here is the program that essentially goes in a loop and increments the number, right? In the beginning, right, we just go to the right. What's funny is that this is pretty much the same thing. We may try to factor it out, right? We may try to factor it out and make back the initial state. We might as well actually rename it to begin, right? So it is something that brings the counter to begin. Right, this is actually pretty cool. Right, if you encounter that, you go to the right, then you go to the left until you, yeah. That's the whole thing, chat. That's the whole thing. Should we try it? Should we try to run this thing? All right, so this one is a counter. So tape 04. We have back though. Oh, that was actually super useful. Oh my god. Yes, it Yeah, I forgot to rename this thing. Yeah, our interpreter actually caught an error, so I didn't waste time implementing this feature apparently. All right, so we're gonna start with the begin, and here is the initial state. Right, in the initial state, we are in increment, we're incrementing it, we're in begin, and we're counting. This is so cool. Yeah, it's counting, right? So yeah, and it's as simple as that. Seriously, like a binary counter in Turing machine, in a pure Turing machine. It's actually that. It's that simple. Can you make it start from 0, 0? Sure. I mean, it's not that difficult, right? It is reversed, actually. Yes, it is reversed. We can. It's gonna be interesting. What's gonna happen when we reach the end, right? At some point, we're gonna reach the end, and since this entire thing is not particularly. Oh, that's very interesting. It actually found, yeah, it basically terminates because it encounters the situation of marker. Yeah, that's actually cool. So you encounter a marker in a state inc, and we don't have that situation here. We never, a handle inc, like marker in a state of inked. All right, so that's very cool. Isn't it cool? Like, I find it fascinating. Like, yeah, it's a programming language. You can program in this shit, and I like the flexibility that you can name state whatever you want. You not necessarily have to use numbers. You can use any sort of symbols. I think it's super cool. Like, look at that. Can we sum up two numbers? That's actually a very interesting question. So, what summing up two numbers would mean? Right, you have two numbers, and essentially you decrement one number and increment another one until one number becomes 0, right? And this is how you can sum them up, right? Essentially, you can have some numbers here. So here's the first number, then you can have a second number here, and essentially the program has to just decrement one number. And then increment the another one, right? And we can try to implement that as well. What do you guys think? Could be actually complicated, but yeah. Anyway, so let me try that. So we need to commit whatever we have already. All right, so implement inc and counter examples. Inc and counter examples, and let's push that right into the repo. So maybe I also need to document that a little bit better. All right, so let's make a small break. I really want to pee. Okay, cool. I'm really enjoying what I'm doing right now. This is actually super cool. I didn't expect that programming in Turing machine would be that fucking fun. Oh yeah, it's almost like brain fuck. It is basically brain. Yeah, it is essentially brain fuck. But it doesn't have loop construction, right? It doesn't have a loop construction. You have to organize the loops yourself. So let's make a small break. Actually, maybe 3 minutes. Alright, let's make a small break and you guys have fun. Yo, welcome back to back. I just thought about pretty cool extension for a Turing machine while I was peeing. Basically, variables. In a very interesting way. Let me show you. Let me show you what I mean. I think it's not Beaver, but counter rather. Look at that. Right. So essentially, when you're going back to the beginning, right, you incremented a number and you're at the right of the number and you need to go back until the marker. You don't really care about any symbols. That's why when you encounter 0, you write 0 back because, again, you have no choice to not write. So what we could do, essentially, also in that extension comments, begin any symbol x and replace it with any symbol x and move to the left, maintaining the state begin. You see? See what I'm talking about? So, and it doesn't care about symbol because it writes the same symbol back, right? So yeah, sort of like a wild card, like any symbol and write that symbol back because I don't care what it is. I just need to go back until the marker. So that would be actually a very useful extension, by the way, in my opinion. Maybe we could extend that even further and maybe being able to assign like variables on the states, but I'm not sure if that would be useful. Maybe it will be useful only for the symbols. We'll see. What do you guys think? Does it make any sense? So, and that way you would replace like these two lines with a single one, and that's quite important. What if we have more symbols? What if we have more symbols? All right. So, yeah, it's kind of an interesting idea. Just wanted to share that. It's kind of an interesting idea, at least to me, I suppose. If you did that for symbols as well, what do you mean I did that for symbols? Right, I just demonstrated this example for symbols specifically. You mean states? I don't know, what do you mean go to? Don't understand. Don't understand. All right. I'm gonna implement like a sum of two numbers, so I'm gonna finish this stream. I understand that nobody gives a shit about this stuff and this is boring. But I really want to finish that because I personally find it interesting. All right. Okay. Now, do I need to do anything? Can I have like I have a lot of ideas, a lot of unstructured ideas in my head. I need to put them to structure. So to sum two numbers in a way I just described, basically in decrementing one number and then incrementing another one, we need to learn how to decrement the numbers, right? So decrementing the number is actually pretty straightforward, right? Pretty straightforward. Essentially, it's the opposite thing here, right? It's the opposite thing. If you have 1, you just replace it with 0 and you're done with it. Okay. If you have 0, you fill it with ones. You fill it with ones until you encounter 1 and you replace it with 0 and you're done with it. You see? So it's kind of a similar situation, but opposite, right? It's exactly opposite situation. So let's take a look at it. So here's the increment. I want to kind of replace a's with inc, right? We want to have like a human readable names here. Let's do dec third. Here's the dec. So when you're decrementing and you encounter 1, you simply replace it with 0. You move in whatever direction, doesn't matter, and you halt because you're just decremented 1 to 0. Right, decrementing 1 to 0 is actually pretty straightforward. Then, if you encounter 0, you replace it with 1 and you move to the right, repeating the decrement. You see? So you can take a look at these two programs. Look at these two programs carefully. They're mirrored. 0, 1, 1, 0, 1, 0, 0, 1. Everything else is the same except these names, but they are just markers. They're just function names. They don't matter. Isn't that fucking fascinating? There's like symmetry between increment and decrement. Like, this is so fucking cool. Like, is it fucking not? It's so fucking cool. Yeah. Okay, so this is the decrement, right? Do we have any tapes with something interesting? Well, this one could be actually interesting to decrement, I suppose. So this one is 0, 2. Yeah. And it fucking didn't work. I wonder why though. Did I not save that? I forgot to save that, yes. All right, so we're gonna start with it. Okay, it's gonna exit because okay, cool. So here's the decrement. Yeah, it's gonna go to the right, fill in everything with ones, then put 0 here, and then we halt. So we just decremented that number. So the original number was what? Was that? So this was the original number, and we decremented it and ended up with this one. What about ternary and higher increments? Would you just have more states? Yes, I think so. Unless we extend the Turing machine to sort of squash some of the cases, stuff like that. This is a good question, Kale Bless. Thank you so much. Yeah, this is actually pretty good question. Yeah, you just essentially have more states. Is this a Turing machine yet or still FSM? When do FSM becomes Turing machine? Turing machine is FSM. Okay. Decrements a number by 1. All right. So all right. So now we know how to increment a number and decrement the number. So we can try to do something like that now. All right. So let's actually have a tape. Let's actually have a tape that does something. Let's actually do like input 05. Input 05 tape is going to be, so we're going to have 2 markers here, right? 0, 0, maybe 1, and then another 1. Okay. So here's the deck third, and we're gonna do add third. All right, and we're gonna do begin. This one is gonna be very interesting. So so initially we start somewhere here, right? And if I'm going to do begin, if I encounter this thing at the beginning, I just keep that thing here, I move to the right, and I switch to decrement. Right, in a decrement I do my usual thing. If I see 1, 0, I put 0 there, and I move to the right. And I need to switch to the state that will transition me to the next number. That's what I need to do. I need to switch to the state that will transition me to the next number. So I'm going to call it next then. So, and what's going to be the next, we don't know yet. So this is basically a transition to the next number, move to the next number. All right, so in a decrement, if you see 0, you fill it with 1, and you keep moving to the right, repeating this kind of thing. What's interesting is that if during the decrement you encounter this kind of thing, that means you encountered, yeah, that's very interesting. So all of them were 0, right? All of them were 0. That means I'm gonna just put this thing here, move to the right, and we're gonna halt. Right, so this is like we reached 0 situation. Right, we reached 0 situation. Cool. Next one is very interesting. We basically move to the right until we encounter this thing here. Right, it's gonna be if On the next state, I encountered a marker. I save the marker back. I go to the right, and I switch to the increment state, which will increment the current thing. And what's going to be the increment? We're going to implement it later. Okay, so if in the next you encounter 0, I just write 0 and I just do right, and I iterate and I repeat this kind of stuff. Okay, so you see, I'm just going to the right until I reach the next number, and then I'm sorry, I just hit the mic. I hope it was not too loud. I didn't mean to do that. All right, in the increment, if it's 0, I do 1. If it's 0, I do 1, and I move to... No, this one is interesting, actually. So... Mm-hmm. 0, 1, I move to the right, and then we have to do something like this, that here. If it's 1, we replace it with 0, move to the right, and repeat the increment. All right, we might as well actually put this thing here. Okay, I need to make it. All right. Okay. So in the counter, so we need a special begin here, that's for sure. Begin. Let's call it previous, I think, maybe just prev. So essentially, after doing an increment, we're going to end up somewhere here. So what we'll have to do here is to go back until here and switch to the next state that will go back here again, right? So it's kind of similar to the begin, right? It's kind of similar to the begin. I may actually copy paste the begin here, but not really. So the previous one is essentially doing, if you encounter this thing, you move into the left and move into the begin. But here, you're replacing this thing with the previous and still moving to the left. I think that's the whole program. Yeah, I think that's the whole program. What happens if you overflow? You will overflow. All right, so here's the begin. When we're here, we go to the right, and that decrements the number. All right, then we decrement the number, and then after that we go to the next. Next brings us to the next number, and we increment that, and then we go to the previous. That goes to the previous number, and then goes to the begin. So that's the whole thing here. That's the whole program. So essentially what this thing will do, it will decrement this number and increment that number, and it will repeat that until we ran out of numbers on the left side, hopefully. All right, let's give it a try. So this is a tape 05, and this is add third. So this is a add third, and this one is a 05. Okay, we're gonna start with the begin. Cool, we are at begin. So oh my god, okay. I left this thing here and it became a part of the tape, but it didn't break anything because we consider by words. All right, so we are in a decrement state, right? We encountered 0, and we now in the next step. As you can see, we decremented this number, right? We decremented this number. Now in the next step, we have to go to the next number. We encounter the marker, the separator of the numbers, and we go to the increment. Incremented the number, and now we have to go back. Now we have to go back, and now we go back again. We go to decrement yet again, and here we have all of the zeros. So that means we're gonna fill everything with ones until we encounter this marker, and we go to the halt, and there you go. So this is a sum of these two numbers. This is a sum of these two numbers. So essentially, if you end up with 0 here, it will fill everything with ones, hit the marker, and terminate. It does sum up two numbers. Okay, let's actually put some significant numbers here. Like, for example, 0, 1, 2. 2 plus 2. How about 2 plus 2? 2 plus 2 should be 4, right? Let's see what's going to happen if we will try to do 2 plus 2. So we're going to do a begin. All right, so let's see what's going to happen. We decrement this number. We increment this number. We decrement it again. We increment it. There we go. So this is the sum, which is 2. So essentially 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2. In these cases, it's multiplied by 0. This one is also multiplied by 0, and this one is multiplied by 1. 2 to the power of 2 is 4, so that means it's 4. Yeah. And we can do some other stuff. I don't know. We can do it like that and run it again. So it's going to begin. There we go. So we just implemented a program that sums up two numbers in a Turing machine. So yeah, that's the only thing I wanted to implement. I do understand that it's a boring nerd shit, and I can clearly see that by the number of viewers on today's stream. I do realize that nobody gives a shit about this kind of stuff unless it's an epic framework that will get you work at Google, dab. Right? This shit is for nerds, so that's why nobody gives a shit about that. Yeah, but I guess I am to be like that sometimes. I kind of find this kind of stuff fascinating. So yeah, I'm really sorry for liking boring ass nerd shit. So what we introduced here, implement some algorithm in I suppose. I'm gonna push that right into the repo. So yeah, everything we developed today is available here in the chat, right? So you can play with the interpreter. I think it's a pretty cool interpreter. I actually had so much fucking fun doing that. I wonder how we can implement multiplication and stuff like that. It's cool. It's not that hard, actually. It's not that hard. So people talking about like a Turing tar pit, it's not that hard. It's pretty cool. And I especially like how you can give, like with this particular implementation, you can give human readable names to the state, and you can treat states as a procedures, right? So in some sense, like you see, like I have like separate like phases of the execution, and it's all readable and maintainable to some extent. I really like that. I really like that. All right. That's it for today, boys and girls. That's it for today. Thanks everyone who's watching me now. I really appreciate that. I'm sorry that I still haven't recovered. I've been sick recently, so that's why it's kind of difficult for me to do stuff. Thanks everyone for watching, and I see you all tomorrow. Hopefully, if I will feel good, I'll see you all tomorrow. We're gonna continue doing game development in C++. Check out the project, of course, if you're interested in this thing. Maybe, probably not, but whatever. So check out the schedule page for more information on what we're developing every day. Maybe our Discord server if you're interested in having conversation with the community. And I see you all tomorrow. Love you all.